Hey, this is Mr. A, and I want to do a mini lesson on determining the number of significant figures. In science class, we're going to be in the lab and we're going to be making measurements and collecting data. Typically, we have to perform calculations on that data, and when we make calculations, our calculator sometimes gives us a lot of numbers. In math class, you might make a calculation. You might be working on a problem and you make a calculation and it just fills up the screen of the calculator with a whole bunch of numbers, and you're confused about how many numbers to write down, and so you say, teacher, how many digits do you want? And your math teacher will say, oh, give me 2 digits to the right of the decimal. Well, that was sort of arbitrary, wasn't it? I mean, what was the reason? Why 2? Why not 1? Why not 3? Well, in math class, they don't necessarily have to worry about significant figures. In science class, we do. Because when we make a measurement, you should know that from previous lessons, that when you make a measurement, you have a certain number of significant figures, both the certain and the one uncertain figure in your measurement. So now you've taken the time to carefully write down all the significant figures. When you make a calculation, you need to retain the proper number of significant figures. We will talk about calculating in the next lesson, but before we can calculate with the significant figures, we need to know how to determine the number of significant figures if you were just given some numbers. So maybe these are numbers that you didn't make these measurements yourself, but you were just given some measurements, and now you have to look at them and you can say, okay, how many sig figs am I actually dealing with? So if you have, the examples that I'm going to be using for this lesson come from a handout that I may have given you. There's 4 different versions. I'm just going to be picking some examples from each of these 4. So if you're paying attention to this video and you have one of these handouts, what I want you to do is to follow along, and when I do one of the examples that is on your particular handout, then I want you to go ahead and fill that in, and then I will collect that work. Determining the number of significant figures. We have basically 3 rules for determining the number of significant figures. And you may have heard these before. Number 1 is all non-zero numbers are significant. So if I give you a number like 1, 2, 3, none of those are 0, so they're all significant. So there are 3 significant figures. Rule number 2. All zeros between non-zero numbers are significant. So if I have a number like 104, this 0 is kind of trapped between those 2 significant figures, and so that 0 is significant. So we would have 3 significant digits in this number according to rule number 2. You'll notice that I'm using digits and figures, that term, interchangeably. My rule number 3 is all place-holding zeros are not significant. These are my 3 rules. Today, I get some questions about rule number 3 because it's kind of hard to understand because it's kind of all-encompassing. If you go out on the internet and you Google rules for significant figures, you may get 3, 4, or 5 different rules. I've looked at them all and I've said, well, basically, the list of rules that are longer than 3 are just rule number 3 expanded upon. And now I feel like maybe I have to expand on my rule number 3. Let's look at it. What is a place-holding zero? Well, trailing zeros in the absence of a decimal point. So if I just write the number 100 without any decimal point, these are trailing zeros. They're just holding place, keeping that 1 over in the hundreds column. There is only 1 sig fig here. Okay? Leading zeros to the right of a decimal point. All right, so say I do have a decimal point, and then these zeros are just pushing the significant digits off to the right here. They're holding place here. So these zeros are not significant. So this number has only 3 significant figures. Now, there is a case when we have zeros to the right of the decimal when they are significant. So if I have a number like 1, 2, 3, 0, 0, these zeros are actually important. These zeros are the result of someone making a measurement on a very precise instrument, and they're telling you this is a precise number. You need to include these as being significant figures. So in this number, 1, 2, 3, 4, 5, this number actually has 5 significant figures. So I've written the 3 rules here, rule number 3, expanded a little bit over here, and let's use this as we go through some of these example problems. An example from version number 2 is 0.40. How many sig figs does that have? Well, this is significant. It's non-zero. This 0 here is a trailing 0 to the right of the decimal point, so it has to be significant also. So this number has 2 sig figs. Okay? From version number 3, how about this number? 30. How many sig figs is there? Again, you can pause this video and see if you can work this out for yourself. Maybe you already know the answer. This only has 1 sig fig because this 0 is just holding place. Let's look at an example from number 4, 0.100. In this number, 1 is significant. These are trailing zeros to the right of the decimal, and they are significant. So these 2 zeros are significant. This number has 3 significant figures. Okay? I'm going to back up and I'm going to do one from version 1. Let's look at this number right here, 0.051. This number is significant, it's non-zero. This number is significant, it's non-zero. Now here's a leading 0 to the right of the decimal. Leading zeros to the right of a decimal point are not significant. So this one is not significant, so we only have 2 significant figures. Okay? So this is just basic stuff, basic determining number of significant figures.